Hi, Object Coder. We're going to look at function passing this time and follow up on our basic function work. So this is the heart of functional programming, is passing functions. And we'll also be using pseudocode again, learning more about that. So let's dive in. Why not, right? All right, so again, I'm going to open up some references here in new tabs. What else do we want? We might want some pseudocode rules, things of that nature. Okay, let's take a look at what we have here. Going to look at some examples. So here are some examples, and the first example is a pretty common function in functional programming called map. I've also called it. You have seen languages call it collect. But it's a conversion really to, we're mapping one element to another. So let's say we have a collection of friend objects and they have all kinds of information in them. They have name, phone number, etc. Well, let's just say we want the names. We want the name of our friends. So we would want to convert this collection to that one. We might want to do it in many different ways. So we don't want to really make custom code to do it. We want to have generalized code, and that's where these functions come into play. Let's see how it works. I like to do a human language first. Just kind of, we're going to get a new collection, new elements here, we'll call it. First off, we're being passed the elements. Those are the old elements or the existing elements, right? And we're getting past this map function, which we'll learn more about in 1 second. So hang on there. We just know we're being passed it. And it returns a new value, a converted value, given a friend. So, or given the object. We're going to construct a new collection, all right? Now we're going to loop over the existing ones. We're going to get a new element by applying the mapping function or running the mapping function with the next element. So friend one, and that would give us this name here, and it would be passed, we'd add that element, new element into, which is just a string, into the new collection and return the new collection. Pretty easy, right? The pseudocode, which we talked about, is really it's almost code and it's also almost human language, so it's kind of right in between. It's user-friendly code though, so we can write that up like this, and then we can try it, and that's kind of the fun part. We could write that up here, and if we want to try it in our lab, we can. This is always optional, but let's see what we have going here, just to play around a little bit. We actually have a few examples, a couple examples here. So we have 4 numbers here, and the first thing we're going to do is just map or convert these numbers to squares. So here's our function, the input, right? The output is that number times that number. So it'd be 1 times 1 for that one, 2 times 2, 3 times 3 for that one, right? So that should give us a list of new numbers that are squares. And then we're doing the cubes for the next time here. And then we're calling that guy right there with the existing elements or old elements and the function. Let's give it a run. All right, there's our numbers, there's our squares, and there's our cubes. So that's what that's all about. I'll let you play with that. You'll learn more. There's some more interesting ones here, computing wages, Fahrenheit to Celsius, that you can kind of take a look at there. Then it gets more interesting here, and we're going to do a find first type of function. And I'll let you play with that there. It's look at that algorithm. We have human, we have pseudocode. It's basically the human is probably easiest to look at, right? We loop. When we find a match, given that match function, which returns true or false for each element, if it matches right there, if it returns true for a given element, an old element, then we return the index. Right, let's give that a play, and I'll let you read through that, not to bore you. All right, I think again we have a couple examples, so let's kind of separate that out for my own organization's sake. What are we doing here? First off, we're getting the first odd number in this collection. Here's our existing or our old values. First odd number, that should be index 0, 1, 2, 3, right? And then we're finding the first number that's greater than 100. Well, there are no numbers greater than 100, so we expect a -1 there. This is -1 is returned when there's no match. Let's give that a run. All right, the first odd is at index 0, 1, 2, 3. The index is returned, by the way, right? Returns the index of the match. The index is often very useful because sometimes we want to get the element before it or after it. If we just get the element, we don't have access to where that position is. So the position of the index is very valuable. That's why we return index there. All right, so that's there. And the match of the first number greater than 100, there is no such number. -1, no match. I'll let you look through that. That was really quick because it's all here for you. Again, it's just like the previous one. There's provided code for you right here. If you open that up, you will see that there are some solutions there for you. So if you look in there, there's how many? Yeah, there's two solutions and 3 that are not, that need to be solved. So again, you just splash your code in there, or your pseudocode, I should say. And again, you're worrying about logical flow, logical thought. You're not really worrying about syntax errors. If this was, let's say, a perfect score here, hopefully it is, it's provided for you, right? And you made a typo here. Instead of let, you had let right there, a typo, that would be okay. Its logical thought is still fine. All right, so have fun, and we'll talk to you soon.